Now, let us see the factors affecting the distribution of insolation. The actual amount of insolation received at a place is depending upon the following factors: angle of incident, duration of sunshine, solar constant, distance between the sun and the earth, and transparency of the atmosphere. First, let us see the angle of incident. Vertical rays of the sun heat the maximum possible area on the vertical rays of the sun heat the maximum possible area. On the contrary, oblique rays have to traverse longer distances before they strike. The larger amount of energy will be lost due to the reflection, absorption and scattering. At middays, the intensity of the insolation is maximum, but in the morning and in the evening hours it is reduced because of the slanting of the rays. Duration of sunshine. Duration of sunlight hours determines the length of the day, which also affects the solar radiation. Longer period of sunshine ensures larger amount of insolation supply. The latitudinal and monthly variations in the length of days have shown in the following table. The inclination of the earth axis, parallelism, rotation and revolution, all these factors combine together to bring about seasonal changes. At the equator, the length of the day and night is about 12 hours, and at the pole it is 6 months. September 21st and March 21st, the sun is overhead at the equator. On these 2 days, all over the earth, the days and the nights are equal. On these 2 days, the maximum amount of insolation is received at the equator and the amount decreases towards poles. June 21st and December 22nd, length of the day in the southern hemisphere increases and in the northern hemisphere it is decreases. On the contrary, at the winter solstice, the southern hemisphere has the longest day and the northern hemisphere has the longest nights. The solar constant. At the energy emitted by the sun varies, the amount of insolation received at the surface is also changes. Distance between the sun and the earth. The earth revolves around the sun is in elliptical orbit. Distance varies from season to season. The mean distance between the earth and the sun is about 149 million kilometers. Earth comes closer on January 3rd, about 147 million kilometers. This position is called perihelion. On July 4th, Earth will be further away, about 152 million kilometers. This position is called aphelion. With the result, there will be about 7% variation in the amount of solar insolation received between January and July. Transparency of the atmosphere. Transparency of the atmosphere is an important control on the amount of insolation that the earth receives. Reflection from the dust, salt and dust particles in the air affects the incoming solar radiation. Reflection from the cloud tops depletes the amount of solar radiation. Gas particles, dust particles, water vapor also affect the incoming solar radiation. Through the process of reflection, scattering and absorption.